All right, let's look at the solving stuff that we were doing today. So solving exponential and log equations. So on the inside here, the first ones we have are exponentials. I know because it tells me, also because x is up in the exponent, and there are no logarithms here. Okay, so the first thing we want to do is we want to get the base with the variable exponent all alone on one side of our equal sign. So over here, there is this multiply by 2 thing. We got to get rid of that. So we're going to divide by 2, both sides. Bye-bye. So then we have 18 to the 6x power equals 13. And it would be really nice if we could do the whole 1-to-1 thing, but we can't. And so now, at this point, we need to take the log of each side. Now, third hour, I don't know if we talked about this in your hour or not. You can really just take the log of both sides. Like, you don't have to take log base 18, and I'll show you why. So the reason we take the log is to bring the exponent out front. And so we'll have 6 times x times the log of 18, which I don't know how much that is, but that's okay. And it doesn't cancel out, it's not 1. So then at this point, to get x alone, I just need to divide the 6 away and the log of 18. So whatever I do to one side, I will do to the other. And so x is equal to all that stuff. Now the reason I said that that's the same as doing log base 18 is because I can't type in log base 18 of 13 on my calculator. We have to do change of base anyways. And so this gets changed into that anyways when I do change of base. So when I type this into my calculator now, we're going to have log of 13 divided by both 6 and log of 18. So we want to make sure we put that in parentheses. 6 log of 18, which is 0.148, which is what they're checking down here in this little checkbox. Okay, looking at the next one, we want to get our base alone. So there's this minus 5, so we got to add 5 to both sides. So I have e to the x minus 1 equals 10. And so now that it is, we're going to take the log of both sides. However, because my base is e, we actually want to use the natural log. So then my exponent flips out front. We can use that product property. So we'll have x minus 1 times the natural log of e equals the natural log of 10. However, the natural log of e is just 1, so we can kind of just ignore that. So we have x minus 1 equals natural log of 10. Then we just add 1. And we're not really adding that to the 10. We're adding that to however much the natural log of 10 is. So now I need to type this into my calculator. So natural log is a button that we have on here. So natural log of 10. End your parenthesis, and then, what is it, minus 1? No, plus 1. So 3.303, which is what it said, 3.303. Okay, so then next we want to talk about solving equations with one logarithm, which these both have. We want to make sure that we get our log on one side of the equal sign all by itself, and so over here we kind of have this 2 in the way. So we have to add that. So I'll have 7 log base 9 of x plus 8 equals 7. And then this 7 is over here kind of in our way as well, so we got to divide that away. So I'll have log base 9 of x plus 3 equals 1. So once our log is the same as by itself on one side, then we exponentiate each side by whatever the base is. So we're going to put this to the 9 power and to the 9 power. The 9 and log base 9 cancel out, so we're just left with the x plus 8. On the other side, we have to do 9 to the first, which is 9. Subtract 8. So x is 1. Which that's what they're checking down here. This is a cool little arrow function. I don't really know where it is on my calculator. I would just plug in 1 right there. But you get the same thing. Okay, B. I feel like this is already alone on one side of the equal sign. So we're just going to exponentiate each side by the base, which is 3. So 2 to the 3, 2 to the 3. Cancels that out, and we have parentheses 9m squared equals 3 to the 8th. I really don't want to do that. That's a really huge number. I don't really have to, because now I'm going to get rid of squared. So I'm going to square root both sides. The square root, if you remember, is really just like taking the half power. So I take half of 8, and that would be 3 to the 4th. Then I just divide by 9 to get m alone. If you remember, 9 is really like 3 squared, and so now that my bases are the same, I can just subtract my exponents, so it's going to be 3 to the 2nd, which is 9, which is what they're checking. And it works out. So 9. Alright, last example. When we're solving with 2 logs, and I feel like I forgot to give an example to third hour like this, so hopefully you're watching. So if I have multiple logarithms, we want to get them on the same side of our equal sign so that we can combine them. So I'm going to have to add this log of x to the other side. So we're going to have log of 7 plus log of x equals 2. And then we use our condensing properties. So if we're adding 2 things, that's going to change to one logarithm where we multiply those 2 things. So 7x equals 2. Okay, so those are using our properties. And if you remember, Kelly, you were asking about that. That's pretty itty-bitty. So hopefully that's okay. Once our log is alone, then we exponentiate by the base. Our base here is 10. So that'll cancel out. We'll have 7x equals 10 to the 2nd, which is 100. Divide by 7. And so x is 100 over 7. Which is what they're checking. And look at that, it works out. Okay, so last one. They're already on the same side, but we need to condense them down to just 1. And so numbers out front are going to become our exponents, and because we're adding, we're going to change this to multiply. So we'll have log base 2 of x to the half times 10 equals 1. And it's times because our pluses change to multiplies. So then once we have a single logarithm, then we exponentiate with the base. So that's 2. That cancels out, and we have, and I'm just going to write this in a slightly better order. So 10x to the half equals 2 to the 1st, which is 2. Next, I would divide by 10 both sides. So I have x to the half equals 1/5. And then half is really like square root, or you can just think about multiplying the exponent by the reciprocal to get rid of it. So we're really squaring both sides to get x equals 1/25, which is what they're checking, which works out. Cool. One other little reminder to third hour, I don't think I mentioned this either. You can never take the logarithm or natural log of 0. It is undefined. Your calculator will give you an error if you try to do it. And so what that means is if you get something like that, you do not have a solution. Like your answer for x would be no solution. Good luck. See you tomorrow.